Hey everyone, what's up? It's Bryan here, and today I am back with a Python-based command line calculator. So what this means is we're going to take two videos. First, we're going to figure out how to accept command line inputs, handle addition, subtraction, and parentheses for order of operations in a calculator. And in the second half of this video, we're going to handle multiplication, division, and finishing touches. The reason why I picked doing a calculator is commonly a leak code style question for job interviews in CS, and it's also just a really good way to learn Python, learn some more about command line, learn some more kind of CS knowledge, and we're going to do this all wrapped in a class so that you get a little bit of object-oriented experience. So without further ado, let's dive right into the tutorial. So how I have my screen set up today is I have my Sublime Text window here with a Python file that I've already saved as calculator.py and a terminal window open on the side. I'd like to point out that my Sublime Text is themed, so yours may not look exactly like this, but don't worry about it. And here we have our tabs size set to 4, and it is set to Python. A few of you asked in my last tutorial how I got syntax highlighting to occur. And the answer to that is when you create a Python file, make sure you add the .py and save it somewhere to your computer. That will let Sublime Text know to start doing syntax highlighting, and you'll get that Python syntax highlighting. Now on the other side here, we have my favorite terminal style window. What I am using is iterm2 coupled with zsh as my shell. If all of this meant nothing to you, then don't worry. Drop a comment in the comment section below. Alright, so on this other side here, I have my terminal window. I am using iterm2 instead of the default Mac or Windows terminal. iterm2 is a Mac-based terminal emulator, and I found it to be kind of cool, and I've customized it a lot. And coupled with that, if you see all of this fanciness up here about the date time, my Mac, where I'm at, and my GitHub status, that is all part of ZSH. Oh my ZSH is a shell change, so I'm not using bash shell. And if all of that meant nothing to you, then don't worry about it. And drop a comment in the comment section below letting me know that you might want a video on all of that. I am a big fan of customizing your workspace, given that you'll be spending many hours, days, and years of your life in it, so I'd be happy to make a video about that soon. Alright, so with that setup explained, let's go to our Sublime or whatever your favorite IDE window is and begin coding. So this calculator is going to be wrapped in a class, and the goal is to have it go through user input. So the goal is that we can go over here, we can call it by saying Python 3 calculator.py. So that's a goal. And then when we run it, we want something to occur. However, of course, nothing occurs yet because nothing is in this file. So to get some type of user input to occur, similar to the last tutorial I did with the Python text RPG, if you saw that before, then we will be doing a similar concept here. By the way, if you are confused as to how to run any Python commands in terminal or how to get Sublime Text or what to edit in or what to install, please go check out my first video in the Python text RPG series, which is setting up your computer to be able to begin programming with Python. Alright, so to begin this calculator.py file, which will contain our calculator class and all of the code needed to run this calculator, we will begin by writing class calculator. So we define a class in Python by writing class, adding calculator, and then ending it with a colon. That indicates to Python that, hey, we're going to have this class, and it's going to take in functions. So let's add a comment to explain what this class does. To do a multi-line comment in Python about functions or classes, you use 3 double quote marks, and then another 3 to end it. So inside this then, I'm using my arrow keys to navigate right now. We can just start typing some information about what this calculator is. In our case, this is a stack-based calculator. And it will implement addition, subtraction, multiplication, division, and order of operations through the use of parentheses. So we can say uses parentheses for order of operation and implements addition, subtraction, multiplication, and division. Really, whatever else you want to write in here is fine. That's just an example of how to write a comment. And don't forget to periodically save as you do this. On a Mac, it's Command S. On a Windows, it's Control S. So I just am hitting Command S here to save the file, and we can continue on. Now, inside a class, you're going to need functions. As I explained in my last Python series, classes allow you to create instances of some object. So imagine that we are writing right now the skeleton, the template of what this calculator is going to look like, and then by calling multiple instances of this class, we can have many calculators created. In this case, we only want one calculator though, which will be used in our command line window on the other side here, and that calculator will receive inputs from Python code that handles command line input. So let's first start by writing our function, which will be calculate. I think that's an apt name. We want this function to basically take in whatever string is given to us through user input, and to process the string so that we can perform calculations and return some result to the arithmetic. So we'll call this calculate. And then in Python, when we are creating a function under a class, if we want it to reference something about itself, then we will write self. Self is kind of like a magic argument in Python, and what we write in these two parentheses after a function are called arguments. So in this case, calculate will always take in itself, which it inherits from the class calculator. However, s will be a string that we pass in through elsewhere in the code, so this is the only argument that we will actually have to worry about and provide. What this means is that if we were to later on in the code call calculator.calculate and then provide self and s, that would error. Instead, we only want to provide string here, and that s would then correspond to this string here that we'd like to process. Alright, so again, we can consider writing a multiline comment as to what this function does, and this function basically takes in a string s and returns a number, which is the result of the calculation. So for now, we can basically write a return statement because we know that we'll have to return to this and figure out the implementation details, which is where this starts to become like a leak code easy, medium, and hard level question. For those of you who aren't familiar, leak code is a very popular and somewhat infamous system that companies and people use to train their coding skills for software engineering interviews. It gives you anywhere from testing the basic knowledge of CS and very Pythonic things to very complex algorithms presented and optimization tricks, things that get into things called runtime and space complexities. And this is stuff that you don't have to worry about at all, but this is where this calculator example comes from. It's a very, very common leak code question, so I thought it would be cool to use to teach you both practical things in Python and get you aware that these more test-style systems exist, and this is also useful to become good at understanding how to pass these tests and understand your own flow of logic in your brain as you code. So here we've now got a class calculator and we have a function calculate. So now we can proceed on to writing more of the code on getting this to work. So I'm going to take a level of abstraction here and say that we know that we have an object calculator and we know that we want to calculate something. But let's, instead of diving into the implementation details of this function, let's take some steps out and figure out how do we feed in information to this now. Well, we know that we can print stuff. When we print lines, print strings in Python, that will be printed to the console. So let's give ourselves a print statement so that we can at least see that our file works, right? So let's write print launching the calculator. If we do Command or Control S to save our file and then hop over to the terminal here, we can run Python 3 calculator, and note that if you typed it before, you can simply hit the up arrow to go through your history of what you've entered, and then we can hit enter and see what it prints out. In our case, as expected, it's printed launching the calculator, and we know that our file is now printing properly to the command line, to the terminal. So what do we want to do now? Well, to actually launch the calculator, we want to create an instance of the calculator class, the calculator object we've defined, right? So let's call that calc, and say that calc equals a new instance of calculator. You can initialize it by just giving it parentheses like that, and then boom, we have that. Now, to take in user input, let's figure that out. Well, we know that we want to take in some strings, so let's call that user input equals an empty string for now. We also want to see if the user input is numbers or parentheses or something that makes sense for a calculator, right? We also want the user to be able to exit this calculator session without having to go through a normal Python method or just closing the terminal. So let's make that easy for the user to exit it, similar to how we did in the Python text RPG. We will create a while loop. So we will do while user input is not in some series of strings that allow us to exit. So let's say that someone might try typing exit, or quit, or stop, or maybe close. Those are some common things that people might type to try to get out of a calculator. So essentially what this is doing is, given this string that we have as empty right now, and we will update within this loop down here as we code, then we know that if the user ever types at some point in the process one of these strings, we will just end this loop. However, while user input is not in one of these keywords, we will just keep doing things in this loop indefinitely. So to do that now, then, it makes sense that we would need a way to grab user input, right? So let's add that. Let's add user input equals some way of grabbing the person's input. In Python, that's thankfully super easy, and it's just input. And inside these parentheses, we can stylize it so that they see maybe a right caret so that they know that they can enter their information here. So if we do that, let's save the file and go back to the terminal and run it again. We see that we've not only launched the calculator, but we have our right caret showing that we can enter things, and we can start typing whatever we want in there. We can type as however much we want and nothing will happen, because that's what we simply have right now. We type exit, then the loop exits and the file closes nicely. So awesome! We have a functioning loop and a command line. This is the basis to writing any command line application with Python, or it can be extrapolated to equivalent languages. Alright, so now that we have a way to take in input, we now want a way to figure out how to calculate it and output the result. Well, that's simple. Let's just create a variable called output. And let's take our instance of our calculator, which we have called calc up here, and let's have calc call calculate, and let's give calculate its string, the string that the user entered, which is user input. Alright, now with this output, we can simply print output, and the user should be able to see whatever it outputs. So to do a sanity check, we can run it again, try typing 5. Well, in this case, calculate has nothing inside it, so we'll simply return none by default in Python. So that is expected, and our file is working. Now, some of you with more knowledge may be thinking that this is quite basic. We could maybe condense these lines, etc. But that's fine. The goal of this is to basically walk you through a very, very basic level of Python through a common classic lead code question. So if I were to be interviewing in a job interview with any company, I would actually like to do a very simple approach like this. That way the recruiter or whoever I'm working through with knows that I can break it down to these very simple steps, and I can explain things without getting complicated and fancy, and I can add in the fanciness afterwards. So speaking of a little bit of fanciness, we might encounter a scenario where the user enters 5 plus A, B, C, D, E, some gibberish, and we want to be able to strip out that gibberish and ensure that we are looking for purely mathematical formulations. We don't want to be calculating A plus B. So to do that, there's a thing called regular expressions. Regular expressions are a thing across all programming languages. It's quite an old system, and it allows you to search for certain letters, numbers, keywords, symbolic formulations, or anything else in a string or input. So to do that, we will import the Regex system for Python, which I happen to know is called re. So we'll import re, and then we will add that into our while loop. So before we accept user input, let's check if user input is some form of gibberish that we don't want to run computations on, because those computations might break our function. So then here we will go to regex, let's call this variable, and re.search. Search is the keyword that will let us search for these things, and we know that we will do some regular expression here and feed it user input. Now, this is where things take a step up in difficulty. Regular expressions have some defined systems of syntax that you can play around with on websites like regexer.com. I highly recommend it. So this is where you just kind of need to know how regex works, and I would be happy to make a video on regex and understanding, ways of combining regex, typing it, using it for common purposes that anyone may want to use. So if you have some purpose that you want to use regex for and you're not sure how to do it, feel free to drop it in the comment section below and I might make a video on regex. But for this case, we want to check if the person has written anything alphabetical. So to do that, we will write A through Z, and then again a capital A through Z. In regex, lowercase and capital may be different characters, so we want to search for both. There's a much more technical explanation of why you have to do this, but I will abstract that away for now. So now that we have this regex search, we basically want to see if there are any results for alphabetical instances, right? So if there are no instances of something that we would want to strip, then we should have regex just be equal to none. None is the equivalent of null in Python, and then we can print, please write an expression or something. This will basically be like, hey, you gave me something that's not 5 plus 6, so write something that is. Alright, and then to close out of this loop, then we can simply do some print statements. Like let's say we're going to close the calculator, and that should be good. So for a sanity check, let's go here, enter it again, launch a calculator, give it A, B, C, D, E, and then it will return none still. That's just a side effect, but it recognizes that that's not an expression, that's not 5 plus 6, so we need to write something. If we type quit, then we can exit and close the calculator. And now a fun little tip, if your terminal window is like mine, getting flooded with messages and you don't like seeing them, feel free to just write clear, and then now we'll wipe away all of those and give you a nice clean terminal to work off of. Alright, so now that we have this nice beautiful loop working for us, we can start to implement some details of actually calculating. In this first part of the video, I think I just want to handle basic operations such as addition, subtraction, and handling a set of parentheses. We're not going to get too wild at it, so hold tight for now. So let's break this down to figure out what we need to start calculating. We know that we're going to return a result, right? So let's just set our result to some placeholder 0, and we know that we're going to return result. Seems like a logical step for now. Then, in the process of us doing calculations, we probably will have some current value that we're at, and we want to keep track of that as we perform operations, right? So let's also add a number called current, and just leave it as a placeholder 0. And our result will probably be, whatever we're currently at and the current. And there's a few ways to go about this, but I'm going to do some foreshadowing and say that it is easier if we basically take our result and then add that, and then add whatever we currently have that we haven't cleared out to result, just as a way to return. So we're going to have some value that we're computing through and some amount that we've already pre-calculated, and the end goal that we want to return is just both of them. This is just my way of doing it, and we will kind of see why this occurs later on. One aspect of this is, we can type in -5 or 5. So how do we handle this minus sign, right? How do we handle the sign? Well, we can create a variable called sign, and we'll just treat maybe 1 and -1 as a boolean for true or false if some sign exists. Feel free to use true or false to indicate some existence of a negative sign. I just think it's easier to go with 1 since that's a positive number, and then if we encounter a minus sign, then we'll just assign sign to be -1. And then I also mentioned that this is a stack-based calculator. So what that means is that there are these two important concepts in CS called a stack and a queue. So we have a stack and a queue. A queue might be the more intuitive thing, so let's start with that. Imagine a queue of people waiting in a line, right? You have all of these people here, and then maybe they're waiting for the cash register here or whatever. Let's just call this, indicate with brackets. When you join a queue, the first person in will also be the first person out, right? So if this person was here first, then they're going to go to the cashier and they're going to get out first. So that system is called first in, first out, which is commonly abbreviated as FIFO. A stack is different. A stack is like we want to be stacking objects on top of a table, stacking plates, stuff like that. So imagine you're stacking plates, then the last thing that you put on top is also the first thing that you're going to take out. So a stack is first in, last out, or more intuitively, last in, first out, which people call LIFO. So in this case, we're going to use this LIFO system for our calculator, which is a stack. So in other languages, there are a lot of ways to initialize a stack and much more fancier syntax. But the beauty of Python is that a stack is just initialized as a list like anything else. So here we just have stack is a list, and we are going to use it like that. Python has methods to pop things off of a list that work exactly like a stack in Java or other languages, and we are going to rely on those. So I'll just leave this comment here for all of you for now, so that you can remember what this stack does. So in this function, we are going to use our stack to push and pop things into it to handle computations. But for now, we also have to tackle how do we even read this string, right? This string is going to look, something like 5 plus 6, or maybe 1 plus 2 plus 3, like that. So how do we start reading that? Well, we can use a few different ways of reading for a loop. Using a for loop or using a while loop. In this case, since we know that the string is a certain fixed size when it comes in, I'm actually going to use a for loop instead of a while loop like we did here. The point of a while loop to me is that there could be an indefinite amount of information coming in and we want to stop on a certain case being triggered. While in a for loop, we know that we want to process all of the string, and the string is already a fixed size, so we're going to go ahead and use that. So for, let's call it SS. In this case, SS will stand for substring. So for some substring in string. So what this means is, as we iterate through this string, which I will put in quotes for clarity, as that's how Python would represent it, then this 1 will end up becoming processed as a substring 1. So that's what we're currently working with in our SS substring. So for every substring in S, we want to do a few things. Well, let's think about this. If we see something that's not a number, we know that we want to do some operation with it, right? So let's say if substring is multiplication or division, we don't want to handle that for now, at least not in this video. So we can actually do if substring is in, and then check for these symbols, multiplication, and let's go ahead and use this / for division. So we can see, hey, if the substring is in one of these things that we don't want to do yet, let's just say this operation is not currently supported. So we know that we want to do nothing with this then, right? So how do we stop running this for loop? Well, in Python, you just use the break keyword and then it will exit. So let's save that and maybe do a sanity check. Let's run our calculator, and let's say, let's do just that. Then we see this operation is not currently supported. It will stop doing any calculations, and then we'll get a 0 because of our return here. There are a few ways that you can avoid this return from occurring, but I don't think it's a huge deal, and I'm going to leave it for the sake of simplicity. So now let's quit the calculator and go back to our code. Likewise then, let's add another if, which is designated by else if, so that we can see if the substring is in an operation that we do currently want to support, such as subtraction and addition. Then we can go ahead and perform the math with it. What are some other cases that we might want to handle? Well, if we see a parenthesis, whether it's an opening or closing parenthesis, we're going to have to do some different things there too. So if that substring is, now you can also do either is or equals equals. I'm just mixing syntax here for the sake of learning. But let's do if substring is equal to a left parenthesis, then we're going to do some, PEMDAS or whatever that's called. So then do more stuff. And then just close that out. If it's a closing parenthesis, even more things. Now, there's something that we're kind of missing here. If we take in a string, and let's say we're at, number 9 or 4, whatever, and the next substring that we get is 9, 10, whatever else, how do we want to update our current? How do we want to handle overflow? So let's actually drop this if out and move that down, because we want to handle numbers first, right? That's the goal of the calculator, is to handle numbers. So we'll do if substring is a digit to check for all of these digits instead of doing, a list of 0 to 9. So if substring is a digit, then let's handle that. And my concept of handling overflow is we're going to be working off of what we currently have, which is 0. Let's say 0 receives a 5. We want to take the substring and make sure that it's an integer. Otherwise, we would be trying to perform math off of strings, and that's not going to make Python very happy. So let's take this substring, convert it to an int, and then let's handle overflow. So if current is already 10, or we encounter a point where we need to up the overflow, then to do that, let's kind of revisit a concept of math. We want to take whatever substring we're bringing in and lift our current number and then add a 1 before it. So we'll just take that and do 10 times current. This will move current into the tens place, and then we will, that should be an add, and then we'll add our current integer in so that it can be lifted, carried, and added. Alright, hopefully we are all on board with that step. And now let's figure out how to handle addition versus subtraction, since for, this to occur, we'll be adding or subtracting stuff. Well, let's look at what might happen. We could get a negative or a positive number in, so clearly we need to be doing something with sign. In this case, since sign is a 1 or negative 1, we can actually use that to our advantage instead of using a boolean. We can use sign as a 1 to multiply it by what our current result is, or sign as a negative, then we can use that to multiply it the other way. So in code, what that is we want to start storing things to result to be able to return something from the calculator. So we will basically add something to our result. Now, this is where you'll have to bear with me a little bit. So we're going to do sign times current. What this means is if our current thing that we're holding in our calculations is, say, a 5 and our sign is currently on a 1, then we're going to add that to result. However, we need to change the sign based on what we see. So this is basically taking what we currently have, what our current sign is, tossing it in result, so that we can start doing different things with our current. So we'll take our current and set that to 0. We are going to reset our current, and then when we see this negative or positive, then we're going to change what our sign is. So if our substring is a plus, then we know that we want our sign to be 1, right? Else, assuming that it's a negative, then you just write else. You wouldn't provide the substring as a negative. Then we know that our sign is going to be negative 1. Now, a lot just happened here. What this is basically saying is if we are at this point where we're only seeing a minus or a plus, you know that a number is going to come after it. We're not going to write minus, minus, or plus, plus. We're going to have a minus or a plus followed by something. Thus, we should take what we're currently working with and what our current sign is and throw it into the result, and then set our current to 0 so that we can start doing more math with our current. Our current is basically our way of currently storing what we are working with. Thus, this will change in preparation for the number that comes next, and we've tossed it into result, and we can start handling more math. If this is feeling a little magical, This all may come together to you once we start adding parentheses and as we finish out this function. Now, seeing what we kind of did here, we're adding sine times current to result, then we should be able to continue that in our return, right? Because we want to be able to return the full amount that we calculated so far, yet this is only occurring on the step where we have a minus or a plus. So we're actually going to update our return line to take result plus current times the sine. That will essentially do what this is, which is taking our work in progress and shoving it into result, which is what we want to return. This is our way of closing out the function because we're not going to end our math problem with 5 plus 5 plus 5 plus and ending with a plus or a minus. It's going to end on a number, so we need a way of putting all of this information out to the terminal. Alright, so with that we have the basic parts of our calculator, and we want to now handle parentheses. Parentheses is where the stack gets involved. Because we have ordered operations, we want to keep track of what is going on in the stack so that we are doing our math in the proper order. So what we are going to do here is we are going to add things to our stack when we see a left parenthesis. We want to take what we've computed up to this point of the left parenthesis and throw it into stack so that we can reference it for later. So to do that, you use stack.append, and then we will just toss in a result. Likewise, signs are not numbers. We don't want to combine that in, so we will stack.append sign so that we know currently if we're working with a positive or a negative in case we encounter them. We are here doing 1 plus 2, and then we might have some sign, either a minus or a plus before here, that we want to consider. So we're at stack.append result and stack.append sign. Now we're going to treat this open parenthesis as if it's an entirely new instance of the calculator. So we should reset sign to be 1 and result to be 0. Now what this loop is basically saying is, hey, anything that occurs in here is kind of sandboxed from what happened out here, right? 2 plus 3 only care that they're being added together. They don't care that 1 happened here. So we're going to treat that like it's happening. We're going to set the sign back to the default value and result back to the default value, so 2 and 3 are in their own little environment being added together. Alright, and that's what happens when we encounter an open parenthesis. So this is kind of where the magic occurs, and why you want to break it down line by line like this. Because when we see a closing parenthesis, that's basically indicating, hey, we want to update our result. We also want to do things with the stack to undo it and leave the stack in a clean state. And we're also done our work, which means current is going to be updated so that current doesn't interfere with things that occur outside of this little sandbox. So to put all of those ideas in the code, let's start with the first part. We know that we're going to have to update result, so in classic trend like we've been doing, let's do result plus equals current times sign. That will take everything and toss it into result. But now, there's more that we have to do. We don't know if this result inside our sandbox was supposed to be a positive or a negative, right? Are we adding or subtracting everything that occurred inside these parentheses? Well, that's where the sign on the stack comes into place, so we can do that. We'll take result and times equals stack.pop. And since we did stack.append here, sign every single time, we know that the first thing that we pop off the stack will be a sign. So to visualize this, our stack will look like, if we're at a negative, it'll be a -1. And then we'll have our actual computation, and then another sign, and some more computation. So in this case, the first thing that we're popping off will always be here, and we know that is a sign. Then we'll do something with our number, and then a sign. So to make sure that we are then getting our value, we just take result and add that. So again, we do stack.pop, and now we have our result added. And then since we are done what we've done in our parentheses and our little sandbox, then we just set current back to equal 0. Alright, now this should be a little bit magical feeling, and it is okay to be totally unsure of why that happens. However, I highly advise, if you're encountering this scenario, that you maybe rewatch the part of the video that I just explained, maybe diagram it out in code, in some type of code comment, to verify that you are following along with what is happening in the stack. A great way is to just write, a comment like I did, toss in some dummy variables, and then just go ahead, work your mind through the examples to make sure that it understands. If you are watching this for coding interviews, you're going to have to do that during your coding interview. They're going to ask you, given this hypothetical input, such as this, what will your stack look like by this point? And you need to be able to walk through your logic and verify that this code is indeed proceeding through the stack and pushing and popping as you expect it to. Note that I'm using push as a synonym for append. Okay, so now that our calculator is essentially done at this stage, let's run it again and see what happens. So if we launch the calculator and do 1 plus 2, a basic test, we get 3. What about 2 plus 3? Does that 3 carry over? We get 5. No, and it doesn't carry over because we are doing this method where we are calling this function that's essentially running sandbox every time. So in between every user input, there's nothing in memory, there's nothing being saved carrying over that's causing any issues. So now let's try something a little more tricky. Let's start adding our parentheses in. You won't see a parentheses start to matter until order of operations occurs with division and multiplication, but it's cool to see that it at least works with addition and subtraction as you would expect. Let's do 1 plus 2 minus 3, 0. 5 plus 5 minus 10, 0. So we know that it can handle single digits, double digits well, it can handle parentheses. If we do 1 plus 5 minus 2 minus 1, we get 3. So it works as expected. So this gives us an awesome basis to pick up in the next video, which will be more complicated and which will handle multiplication and division. That is where the parentheses and order of operation gets all tricky, and I want us to make sure that we have a solid understanding of what this stack is doing before we dive into that. So I'm going to take this time to finish up this video, release it, gives ourselves some time to digest, decompress our thoughts, and then I will be back with part 2 of this video in about a week or so, where we implement multiplication and division. All of this will be pushed to GitHub later on an open source repo, so you can look at my code compared to your code for any debugging purposes. But in the meantime, if you need one-on-one help, check out my Patreon. There are ways to get one-on-one tutoring in CS there and support with these projects. Alright, so I'll see you guys next time for part 2. Hey again, it's Brian, and I hope you enjoyed the video. If you did, please consider liking, subscribing, sharing, or doing whatever else you can to help support the channel. If you enjoyed this video, please subscribe, stick around, and we hope to see you next time.